Hello, my name is Paul Thomas Edward Cusick. I am an engineer by education. I do research in pretty much every field that universities teach in. This particular paper is a paper getting acquainted with astrotheology and AT math. The AT stands for astrotheology, so it's astrotheology math. The word astrotheology came from 2012 when I wrote a blog called Astrotheology Cusick's Universe, in which I argued that God left his fingerprints on the physical universe. But since 2012, I realized that I don't think you actually can come to that conclusion just based on physics alone, because the universe is essentially energy. All the mass can be converted to energy, all the motion can be converted to kinetic energy, so it's all energy. And of course energy can't be created or destroyed, and neither can God. God's the uncaused cause, but the universe is an uncaused cause. The superforce compresses the material together, and that's what astrotheology is all about. Anyway, I will just run through the background of the mathematics that underlie astrotheology. There's calculus, algebra, linear algebra, and geometry. So basically university math and high school math. And we'll begin the talk. So in this talk we attempt to summarize some of the findings from the AT math solution. We see how calculus, linear algebra, geometry, and algebra work with basic equations of physics. The physics is very basic, first year university physics, high school physics. So I think that most of it could be learned by students before they leave high school, if the curriculum were geared toward it. And it wouldn't take much to teach them astrotheology math. So in calculus we have, to nullify calculus in mathematics, to bring it to a convergence, you have where y equals minus y prime, or the function is equal to the negative of the derivative. So the position, the velocity, and the acceleration are all equal, which is equal to 1 over root 2, which is equal to 0.707. And when y is equal to sine theta, minus y prime is equal to minus of a minus cos theta. So sine equals cosine. So force is equal to sine, we see there in line 4. And momentum, capital P with the vector sign over it, is minus cosine. And force, of course, is equal to ma from Newton. And momentum is equal to mv, and v and a are equal. So momentum and force are equal. The derivative is equal to the function, in other words. Force is also equal to the gravitational constant times the mass of 1 times the mass of the second divided by r squared, the distance between them squared. But we take one of the masses to be 1 and the distance r to be 1, so we just end up that the force is equal to mg. So g equals a equals v. So another important parameter or an equation in astrotheology is the Clairaut differential equation, and that is the second derivative of energy with respect to time less the gravitational constant equals 0. So the second derivative with respect to time is equal to the gravity. If we integrate the energy, the derivative of the acceleration of energy, we integrate it twice, we end up with g cubed over 3 equals e. And so we know that g is equal to 6.67 cubed divided by 3 is equal to 0.99. It's approximately equal to 1. In linear algebra, we have, interesting, the determinant times the eigenvalue times the eigenvector times the eigenfunction. And they all work out, I showed in another talk, that they all work out to be what I call G naught, which is 6.52. And from using Mathematica, the programming computer language, it solved a system of equations of 11 equations, as we shall see. And the result was that G naught is equal to pi divided by the ln of 1.618. 1.618, of course, is the golden mean. So pi divided by the ln of 1.618. I don't know why that is. Someone else can think about that and maybe come up with a reason why that is. So there's your 11 simultaneous equations. Probably the most important, well, the two most important ones are at the top. The mass is equal to the ln of t, and then E is equal to 1 over t. And the cross product of energy and time gives you space. So space is equal to the magnitude of E times the magnitude of t times sine theta. And the momentum, P, is equal to mv equals cos theta, which equals force equals ma equals sine theta. So cosine equals sine, as we've seen before. And rho is the density of the material in the universe, the ether, mass over volume. And from Hooke's law, stress is equal to Young's modulus times the strain, and the Young's modulus for the universe is 0.4233. We'll encounter this a little later in the escape velocity, universal escape vector. 0.4233 is just pi minus E, which I called Q's. And then the Reynolds number is equal to 0.402, which is the inertial forces over the viscous forces, which is equal to ma over 1/2 rho v squared. That rho again is the density. And then the kinetic energy, which is time, is equal to 1/2 mv squared, we all know, and potential energy was mc squared, Einstein's equation. X squared plus y squared equals r squared. That's the equation of a circle. So that reduces, when x and y are equal, it reduces to x is equal to 1 over root 2. And then force is equal to gm, Newton's gravitational equation, which I explained earlier. And there's the solution of those equations is pi over the ln of 1.618. So where it all began, I think, for the Greeks anyway, with geometry, A is Pythagoras, a squared plus b squared equals c squared, which is the equation of a circle again, and x is equal to 1 over root 2, which is equal to the position, equal to the velocity, equal to the acceleration, or the function equals the derivative, equals the negative, actually, of the second derivative. So velocity and acceleration give you momentum and force. The force is sine theta. Acceleration is, momentum is cos theta. So we set them equal. So from Euler's trigonometric identity there, we have sine squared theta plus cos squared theta equals 1. Theta is actually t, time. And so it's 1 over root 2 squared plus 1 over root 2 squared equals 1, and that's true, 1 equals 1. So in physics, we encounter again the cross product of energy and time, which is space. So you have these two vectors, energy and time, rotating relative to each other. And when they hit a critical angle, the space is fixed. It all, that's the solution of the 11 simultaneous equations. So we say space equals time, and from Einstein, and so if we have space and time equal, then energy is equal to 1 over sine theta. 1 over sine theta, of course, is cosecant theta, which is equal to the speed of light. It's the function for the speed of light. It's asymptotic to 3. So and mass is equal to the ln of t. So the derivative of the mass with respect to time is equal to 1 over t. And time is equal to the kinetic energy, which is 1/2 mv squared. Again, potential energy equals mc squared. Total energy equals kinetic energy plus potential energy, which is equal to, if you put the speed of light c in the kinetic energy equation, you end up with 1/2 mc squared. So 1/2 mc squared plus mc squared is 1.5 mc squared. And we also know that the total energy is equal to the mass times 1 over 2 pi. 1 over 2 pi is 1 radian. So if we set those equal to the total energy, we have the mass comes out to 117.89, which is the last stable element in the periodic table. It's actually 116, and then there's 2 unstables that round out to get to the noble gases. So if we have the energy equal to t squared minus t minus 1, which is the golden mean parabola, and we take the derivative of that equation is 2t minus 1, and we also know dE by dt from the last slide is equal to 1 over t, so we can set those equal to 2t minus 1 equals 1 over t, and t comes out to be 1/4, 1 over 4, which is the period. And we know the mass is equal to 4, so time is equal to 1 over mass, mass is equal to 1 over time, 1 over time is equal to energy, and energy and mass are equivalent, something else Einstein taught us. So now we turn to the universal escape velocity. The formula is given by the velocity is equal to the square root of 8 pi times the gravitational constant g times rho divided by 3, all times r. So we'll take r as 1. The square root of 8 pi is the period, and 6.67 is gravitational constant. The density of the universe is 4 over pi, and 3 is equal to the eigenvalue, all times 1. And that comes out to be 2.667 squared, which is the superforce squared. So that's what it takes to break free of the universal acceleration, is the superforce, which is compressing the universe, which is like an ellipsoid, a 1 by 8 by 22 ellipsoid, or a 3 by 24 by 66 ellipsoid, and it's being compressed by the superforce 8/3 or 2.667. So when we solve for v, we end up 1.11.09 or 1.11, which is equal to 1 over c squared. And if energy is 1, then energy over c squared is equal to mass. So the velocity equals the mass of the universal escape velocity. So we have here 2 bar magnets with a north and a south pole at either end. And when you take the 2 bars and try to push them together, there's a resistance. We did this as an experiment in high school. And you can press them together and the resistance builds, but once you get to a certain point, you have a rupture, and you have the 2 poles, 2 bar magnets come touch each other, come close enough touch each other. So that is the same as like Hooke's law. What I've used there is the modulus of elasticity from Hooke's law is 0.4233. It's linear, and there's a rupture point at the end when you plot it on the force versus the position axes. So we know the force in a spring is equal to minus ks. The minus is because the direction coming together is the compression of the force. So the force is 8/3, which is 2.666 for the superforce, equals minus 0.4233 s. S, so the position is equal to 6.3. 1 over S equals 1 over T equals E. Energy is 1 over time. Space and time are equal, so 1 over S is equal to 1 over 6.3 is 1587. And that number crops up a lot, 1587. It's 1 over 2 pi. So the total energy we know is equal to the mass times 1 over 2 pi. And the mass is equal to 1, which is equal to energy. Mass and energy are equal. Energy is equal to 1. And we know when we take pi and plug it into the end of the cycle, when we plug it into the golden mean parabola, we have pi squared minus pi minus 1 is equals 5729, which is degrees, which is equal to 1 radian. And here we have a plot, same plot, f equals minus ks. This time we just show the area under the curve, which is equal to the minus of the work done. So the area is minus work is equal to minus 1/2 base times the height, so 8/3 is the force, 6.28 is the, or 6.28 is the position. It's equal to minus 0.8377. We take the inverse sine of 0.8373. We have 1 over 100,767, which is the mass of hydrogen. So it's approximately equal to 1, but it's 1 over the mass of hydrogen, proton. So we have in algebra the golden mean parabola t squared minus t minus 1 equals E. And the coefficients there are 1 in front of t squared and minus 1 in front of t. So we know energy is 1. We can say that 1 over t times t squared, so the one of the t's will cancel. Minus of the negative work minus 1 equals E. So you have time is equal to minus, or time minus of a minus 1 equals E. So we have that T is equal to E times equal to energy, which we know also from E equals 1 over T. So when we have the force is equal to the Newton's gravitational equation minus mg, again it's minus because gravity is compressive, is equal to the minus of this ks of the spring. The minus signs cancel, but you have the mass is 4. The mass being 4 comes from the kinetic energy T equals 1/2 mv squared. So V is equal to 1 over root 2 squared is 1/2. And we know that the time is 1, so 1 is equal to 1/2 times 4 times 1/2. So 1 is equal to 1, and that's true. And this is the most important diagram in astrotheology. It's a plot of the energy and the time, and it shows the ln function there, mass equal to ln of t, which crosses the x-axis or the t-axis at 1, t equals 1, and energy is 0, and it continues along until you hit time is equal to pi. That'd be a full cycle from 1 to pi. And the other equation there we have is y is equal to e to the power minus t, which is the solution to y equals y prime. So mass is equal to ln of t, which is equal to ln of 1, which is 0, so the mass is 0. Mass is potential energy, so 0 c squared, plus the kinetic energy is time, which is 1. The total energy is 1, which we know to be true. So here we see the energy and time vectors. Time is the horizontal vector there, 1, and the energy vector 2, which comes from the Clairaut equation. And the distance between the tips of those two vectors is the square root of 3, which is the eigenvector. And when you take the cross product between the time and the energy, you end up with the third vector that's vertical there, 3-dimensional, is space, which is equal to 4/3, so 1.3333. So if we take the golden mean parabola, t squared minus t minus 1 equals the energy, then the square root of 3 plugged into the golden mean parabola gives 2.67 as the superforce, is the energy. And if we take the cross product of energy and time times sine theta, it's equal to space. So we plug our values in, 4/3 is equal to energy 2 times 1 sine theta. Sine theta equals 2/3, or g. We know that force is equal to sine theta, so we can set those equal, which means that force is mass times g, Newton's equation, and so mass comes out to be 1. So we see that AT math, astrotheology math, is a relatively simple system compared with something like relativity. It's highly accessible for the average student. The solution has a wide range of effects for two-pole problems, which is because sine and cosine at t equals 0 sine is 0 at 0 and cosine is 1 at 0. So we have two polar opposites there. Where the compromise meets is at pi by 4, which is 45 degrees, and the resulting, adding the two of them results in square root of 2. So I've written over 100 papers, maybe 200 papers that have AT math in the title, that are solutions from economics to political science to medicine. And there are a couple of references. That's my first paper, I think it was, Astrotheology, Cubic Universe, Journal of Physical Mathematics. And the second one there is the Hodges conjecture, which has a reference to a lot of different papers I've written that might prove helpful. So that's my talk. I hope you've enjoyed it, and that's the end. Thank you very much.